Good morning. The course content is VLSI design. We are going to see about the silicon, PN junction and transistors, operation of MOS transistors, CMOS circuits and the fabrication steps involved in the CMOS circuits. So, integrated circuits. It is nothing but the integration of, that is, many transistors can be combined together to form a IC. That is, nowadays we have many integration, that is starting from the small scale integration, then medium scale integration, then large scale integration, and then we have the very large scale integration circuits. So this complementary metal oxide, that is CMOS circuits, is the base for this very large scale integrated circuits, as it was fast and it is cheap and it is the low power transistor circuits. So why VLSI design? So we can consider this for the three conditions, that is money, technology and civilization. So the annual sales, this is the general content where we can go with the silicon. We can see directly about the first integrated circuits in the 1958, where we use the flip-flop using two transistors, and next by 2003 the Intel Pentium 4 microprocessor invented this by 53% compound annual growth, and then the mass integrated circuits by 1970, and in 1980 the CMOS processor circuits. And here comes the Moore's law, where this Moore by 1965 he really calculated all this, as I said earlier, about the small scale integration, medium scale, large scale, and then now very large scale integration. The transistor counts will be doubled every 26 months, as it was really happening in every 12 months right now. And this was the Pentium 4 processor. This is the circuit, you can see. This is the chip, integrated chip actually. And this is the modern transistor using very recent technology, that is few micron technology. This is the MOS transistors, where you have the gate, that is P and N junction with the source, gate and drain. Here is the polysilicon material and the silicon dioxide. This silicon, we cannot replace this silicon, since this silicon acts as a conductor, semiconductor and insulator. At all the conditions this silicon works out, and it is easily available in it is the natural resource available in our country and in the nation actually. And here this bulk is completely made up of silicon. So as I said before, it is very cheap and it is very quick to the market, all because of this silicon. And nowadays they are changing this silicon into germanium. So let us see the research later. Next, the NMOS operation, where the body is completely tied to the ground, so no current flows and the transistor is off in condition. And the PMOS, here the gate is low, transistor is on, and the gate is high, the transistor is off condition. This is the CMOS inverter, CMOS complementary metal oxide inverter. So here we have the ground and VDD. So this is the NAND gate, where we have the inverter symbol over here. So this is the CMOS fabrication. Here lithography is the main process involved in this fabrication process. This is the fabrication steps, that is oxidation. Next step is photoresist. Next is the lithography. Lithography is nothing but the photoresist to ultraviolet rays. Next is the etching process. This is nothing but the pattern where we can mask or where we can remove all the unwanted things. This is the patterning. This is the diffusion content, and this is metallization, that is electrical connection we are going to give for all those patterns. And this is the design rules. We will be following few rules over there. So and this is the design rules, and this is the pitch diagram. So finally, MOS transistor or stack of gate oxide and PN junction, and finally we are completing by giving a mask. So CMOS, this is the overview of CMOS circuits. Thank you for the session.